Hello friends, welcome to SR Physics Academy. Today we are going to discuss about speed and velocity. Speed is a measurement of how fast an object is moving through a path. It does not matter where you are driving to, how many turns the road takes. If you are on a big circular track, speed is only concerned with how much ground you have covered in the time you have been driving. So the rate of change of position of an object with the time in any direction is called its speed. So now what is speed? Speed is the rate of change of position of an object with the time in any direction. So here it is the direction, it's not specified. It is any direction is called its speed. Now, what is the speed of moving object? It is equal to the distance travelled by the object per unit time. Mathematically, speed equal to distance travelled by time taken. Speed has only magnitude and no direction, so it is a scalar quantity. As we know that scalar quantity means only consider magnitude and no direction. Also, the distance travelled by an object is either positive or zero. It's not, the speed may be positive or not, but never negative. The SI unit of speed is meter per second. So how it's meter per second? We know that speed equal to distance upon time. So what is the unit of here speed? It is meter and time is second. So we will get meter per second. Now the CGS unit of speed is centimeter per second. The dimension formula of speed is m0l1t minus 1. Now, as we discussed now, different types of speed. First one is uniform speed. Second one is variable speed or non-uniform speed, average speed, instantaneous speed. Now, we will discuss one by one. What is uniform speed? An object is said to be moving with uniform speed if it covers equal distance in equal interval of time. Then we can say it is an uniform speed. Now, non-uniform speed. An object is said to be moving with variable speed. In this case, it covers unequal distance in equal interval of time. So we know that here uniform speed means what? For example, motion of heavy vehicle like trucks on highway, it is a go uniform speed. Now variable speed, for example, motion of bike in city or busy road, it is an example of non-uniform speed. Now we will discuss with the example. In this case, here uniform speed and non-uniform speed, here equal distance in equal interval of time. So that bike will go here, equal distance means what? Each distance it is in 6 meter, 6 meter, 6 meter, and time has taken here 1 second. So in each distance, 6 meter distance, it has taken 1 second. So that means it is an uniform speed. That means what is a uniform speed? The object moving in equal distance in equal interval of time. So here distance are here 6 meters. So all are equal distance in equal interval. So here what is the time taken here? 1 second. So then we can say it is an equal distance and equal time. Then we can say uniform speed. Now what is non-uniform speed? In this case, see the distance here 5 meter. So in this 5 meter, how much time it has taken? 1 second. Next it is moving 10 meter. So same, that time is also 1 second. Again it is the speed low 6 meter. The time is 1 second. So just now I told you here, non-uniform speed, suppose the motion of a bike in city or busy road, it will get variation. That means 5 meter, it will get 1 second, it will move 5 meter only. Then it is then 10 meter. So this is, then we can say, unequal distance in equal interval of time we called as non-uniform speed. So now it's clear what is uniform speed and non-uniform speed. Equal distance and equal interval of time, unequal distance and equal interval of time is called non-uniform speed. Now third one is average speed. So now first, what is the types of speed? First one, uniform speed. Second one is variable speed or non-uniform speed. Then third one is average speed. So what is average speed? So as we know that most objects or bodies do not move at a constant speed. For example, if you take a train, start from rest at a motion, move faster until it reach a constant speed, then it slow down to a stop at the next station. So it is therefore more useful to define in that cases we can take it average speed rather than actual speed. So here for an object moving with variable speed, the average speed is the how to calculate the total distance travelled by total time taken. So what is the formula of average speed? We are taking here what are the total distance travelled by total time taken, then we will get average speed. Next is the instantaneous speed. The speed of any particular instant of time or a particular point of its path is called instantaneous speed. So here what did you understand in this case? For example, Rahul uses a stopwatch and measure 1.6 second. Okay, in this case, Rahul is use the stopwatch to measure 1.6 second as the car travel between 2 points. Okay, so here 2 post it is an 20 meter. If you take the 20 meter, then what is the instantaneous speed? So how we will calculate here? That we will get 20 divided by how much it has taken the time clock? It is 1.6 second. So we will get 12.5 meter per second. So in this case, so see in this case we don't know exact here that the car may have been speeding up or slowing down during that time, but we can estimate this is the value we will get 12.5. So in this way we are calculating the instantaneous speed. Next is, so this is already we discussed what is uniform speed and what is non-uniform speed. So now it's clear what is a uniform speed. It is an equal distance and equal interval of time. And what is non-uniform speed? It is an unequal distance in equal interval of time. Now what is velocity? The rate of change of position of an object with the time in a given direction is called its velocity. We know that here the term velocity and speed give us an idea of how fast or slow of an object is moving. But we come across the situation where we need to identify which of two or more object is moving faster. So one can easily tell that faster of the two if they are moving in the same direction on the same road. However, if their direction of motion is in opposite direction, then it is difficult to determine the fastest. In such cases, the concept of velocity is helpful. See, in this case, this is we can calculate is a straight line speed because it is no direction it is showing. That is directly we can calculate the speed. But in this case here, if they are moving in the same direction or that is no problem. But in opposite direction it is moving, then it is difficult to determine how it is fastest. In such cases, so we can use it here, the velocity is very helpful. So speed and velocity can be a little bit confusing for most of us. So then the difference between speed and velocity is that speed gives us what? An idea of how fast an object is moving. The velocity not only tell us its speed, but it also its directions the body is moving in. So we can define the speed is a function of, so we know that the speed is calculating only the direction. So we can say that how much distance traveled. But here suppose we are taking the velocity, the function of its displacement. So it is defined how we can define the velocity, the rate of change of position of a time with a given direction we called as its a velocity. So velocity equal to displacement by time. So we know that displacement it is showing the direction. Thus velocity has both magnitude and direction, so it is a scalar quantity. The velocity can be positive, 0 or negative. That it is already we discussed in the last classes. That means it is a displacement means it will get positive, 0 or negative. The SI unit of velocity is meter per second. Same case as a speed because the displacement it is measuring initial to final minus initial. Okay. So it is a shortest path, that is also distance is meter and time is per second. The CGS unit of velocity is centimeter per second. The dimensional formula of velocity is m power 0 L1 t minus 1. Now same type just we discussed their types of velocities here. Here also different types of velocities. Now first one is uniform velocity, variable velocity, average velocity, instantaneous velocity. So uniform velocity or variable velocity is another name is we can call this non-uniform velocity. So here an object is said to be moving with uniform velocity if it covers equal displacement in equal interval of time. So it is not too much difference is not there in speed and velocity. Here it is an equal, their equal distance, in this case equal displacement in equal interval of time, because we know that velocities it will come equal displacement. Now here non-uniform velocity or variable velocity, in this case an object is said to be moving with a variable velocity when if either its speed changes or direction of motion changes or both changes with the time. So that is we can say that unequal displacement. Now next is average velocity. For an object moving with a variable velocity, the average velocity is defined as the ratio of total displacement to the total time interval in which that displacement occurs. So as we know that here average speed means what? The rate of change of distance with the time. But here average velocity is the rate of change of displacement with the time. So mathematically we can say that average velocity equal to total displacement by total time. Next is instantaneous velocity. See, instantaneous velocity is the velocity of a body at any given time, but average velocity is what? Total displacement and by total time. So we can, in this case here we can say that delta x by delta t. Here delta x is what? Total displacement of the body, and delta t is the time. So average, in this case average velocity always less than or equal to the average speed. So here instantaneous velocity, we can say that the velocity of an object at a particular instant of time or a particular points of its path is called its instantaneous velocity. So here the limit is there. Then in this change in change in displacement by change in time. So in this case, how does instantaneous velocity differ from average velocity? So we know that here average velocity of a body is defined as the change in position or displacement is divided by time taken in which that displacement occur. But instantaneous velocity of a body is the velocity of a body at any instant of time or any point of its path, then we can say that it is an instantaneous velocity. Now, so just we will discuss with the here image. Here, let us look at some example here. As we can see that here different objects can have different speeds or velocities. Since the direction of all the objects are same here, we can also say that the magnitude of velocity is same as the speed of the object. So in this case, what is the difference between two identical objects are traveling at different speed? Nearly everyone know that here one moving faster, then that means the one with the greater speed will go farther than one moving slower in the same amount of time. Either that or we can say the one moving faster will get where it is going sooner than the slower one. So whatever speed is, it involves both distance and time. So once more I am showing here, in this case look at this example where the 5 example here different speed and have to travel the same distance of 10 kilometer, as we can see the plane first and is followed by the train, then a train, then car, bus and the cyclist. So in this both cases, in this all different speed. Now, for example, if it take 2 minutes and 30 seconds to cycle around the rectangular path, its dimensions are 45 meter and 30 meter, you end up in exactly the same place that you started. Calculate the distance travel, displacement, average speed in meter per second, average velocity in meter per second. See, as we know now, what is uniform, what is speed and what are the types of speed. That means it is an uniform speed, non-uniform speed, average speed, instantaneous speed, and I know you know that how to calculate with the formula. Next is just now we learned what is velocity and types of velocity. Now we are taking here that together one example here. In this case, if it take 2 minutes and 30 seconds to cycle around the rectangular path. So this rectangular path, it has given 45 meter and 30 meter. So you end up in exactly the same place that you started. So we have to see, this is starting point and this is ending point. So in this case we have to calculate here. What we have to calculate? Now we know how to calculate the distance traveled, we know how to calculate the displacement, and we know that average speed and average velocity. Okay. So in this case, see what are the given data given? So time taken 2 minutes 30 seconds. So we know that 2 minute means it is an 60. So 2 into 1 minute equal to 60. So 2 into 60, because the both here the minutes, here it is a second. So we are converting in second. So 2 into 60 plus 30. So we will get 120 plus 30. So we got it 150. So total how many minutes, how many second it has taken? 150. Now we are taking the perimeter of the rectangle also. They are giving in the question 2 into 45 meter and 30 meter. Okay. So length and breadth. So 2 of length and breadth, length plus breadth. So we will get 2 of 75. We got it 150 meter. So in this both cases we got it here. So now we got the perimeter of the rectangle and time also we got it. Next is we have to calculate the distance traveled. We know that what is the distance traveled here, what are the total distance? It is nothing but perimeter of the rectangle equal to 150 meter, because we know the distance means total path to calculate it. So what is the total path from this distance here and here to reach? Okay, so that is total length covered, it is 150 meter. Next is displacement. The displacement we which one is initial point, which one is here final point. Okay. So in this numerical, means in this problem, what is here the final initial point? This is the initial point starting. And which one is the final point? Because it is one round it has taken, again it is reached the same point. So we know that displacement equal to what is that final point minus initial point. So in this situation, what is the displacement? Is 0. Okay. So distance means total length covered. So that means nothing but perimeter of the rectangle. So here we got it 150 meter. But here displacement means where it is initial, where it is final, it is reaching the same point. So then that cases the displacement is 0. Now we have to calculate the average speed according to our question. Average speed equal to distance travelled by time taken. So what is the distance here? 150. And what is the time taken here? 150. So we got it 1 meter per second. Next is we have to calculate average velocity. So here average velocity in this case, what is our formula? Displacement by time. So you have to remember, when it is the speed, the distance by time, and when it is the average velocity, then displacement by time. So what is here? Displacement is 0 by time. We know that 150 seconds. So we will get 0 meter per second. So in this case, we got it distance, displacement, average speed, average velocity. Now just key points between speed and velocity. Just some points I have written here. The distance travelled by the body in a given time interval is called speed. The movement of something in a definite time is called velocity. Next is the speed determine how far something move. On other hand, thus velocity determine in which direction something is moving. So direction is something means it will go to, what is that, north direction, east direction, south direction, like that. It is specifying with the direction, that is nothing but velocity. Speed is a scalar quantity, that's we know that scalar quantity measure magnitude And velocity is a vector, that means both magnitude and direction. That means we can say the 5 kilometer north, but in it is a scalar or speed, we can just we said it is 1 kilometer and only 5 kilometers specify. It is we are not worried about any direction, but in vector quantity or it is we have to specify both the magnitude and direction. Then we have to say that 5 kilometer north direction. While speed calculate the rate of change in distance only, velocity calculate the rate of change of displacement. When the moving object returns to the starting point, the average velocity will be 0, but this is not the case for the average speed and velocity. Hope you understood. If you enjoyed this class, please subscribe our channel for more videos. Thanks for watching.